Good morning, students. How are you? Dear students, today, in the continuation with the video lectures for chapter 3, that is motion in a straight line, we are discussing with the part 10 of the video lecture. And in this video lecture, we will discuss about the topic acceleration, as we had discussed about velocity, instantaneous velocity, average velocity, and numericals based on this we had discussed in the previous videos. So today we will discuss about the topic acceleration. What is the meaning of the term acceleration? Acceleration, generally you use the term acceleration while when you are driving your vehicle, driving your motorcycle. In that context, you use the term acceleration, and the acceleration can be discussed as the change in velocity with respect to time. Means, if you had started your bike, if this is your bike, this is your bike, and you had started this bike with velocity 30 kilometer per hour, and a vacant road you are getting, and after that you had started the riding your bicycle with 70 kilometer per hour, and here the time between here, the time is 10 o'clock, and here 10:30 a.m. Means in 30 minutes you had changed your speed from 30 kilometer per hour to 70 kilometer per hour. Means with the variation of time, the speed is your speed is increasing. Means obviously you can say that, okay, obviously you can say that the your vehicle is accelerating or increasing its speed. But if you are started driving your vehicle at 30 kilometer per hour, and after 30 minutes if your speed becomes 15 kilometer per hour, then your speed is decreasing. Means some retarding force is acting on your vehicle, and due to that your speed is decreasing. So that is the case of negative acceleration or deceleration. So this acceleration term was first given by Galileo. Galileo has discussed the term acceleration by various of his thoughts, on the basis of various of his thoughts, and he had defined the acceleration as acceleration is the change in velocity with time. Acceleration is nothing, acceleration is change in velocity with time. And by acceleration you can say that how fast the velocity of a body changing, how fast the velocity of the body is changing. By acceleration you can say how fast. This is the physical significance of the term acceleration. Since it is change in velocity, so you can say that acceleration is a vector quantity. You can say that acceleration is a vector quantity. It is a vector Acceleration is a vector quantity because velocity is a vector quantity and acceleration can be defined as change in velocity. SI unit, its SI unit of acceleration is meter per second square. SI unit and CGS unit is centimeter per second square. Its dimensional formula is MLT minus 2. MLT minus 2. How it is possible? Because you can write here as, you can understand it like this. You can understand it that acceleration is change in velocity upon time. Change in velocity upon time, and change in velocity delta v. Change in velocity can be written as delta x upon delta t, that this is the velocity upon time, and it can be written as delta x upon t square, and delta x is SI unit of displacement or distance is meter and time is second, so it is written as meter per second square. So how can you say that a body is accelerated? How can you say that a body can be accelerated? Since here I want to mention that acceleration is equal to change in velocity. Acceleration is equal to change in velocity upon time. Now, on what factors the velocity depends? Velocity depends magnitude of the speed and direction. Magnitude of speed and direction means if magnitude of speed is changing, then also you can say that body is accelerated, and if direction of body is changing, then you can also say that the body is accelerated. Means to say that if a body is moving with 3 meter per second in north direction, if a body is moving with 3 meter per second in north direction, so let the body to continue moving in north direction, but this is changing, this becomes 4 meter per second. So dear students, we are talking about acceleration, and acceleration of a body can be notified or viewed either by change in magnitude of speed or the direction. And I had taken an example. Suppose any bike is moving with 3 meter per second in north direction. If the bike is continuing to move in north direction, but the magnitude of speed is changed from 3 meter per second to 4 meter per second, then you can say the body is accelerated. Or if the magnitude of speed is 3 meter per second but the direction becomes south direction, then also you can say that the body is accelerated. The sign of velocity and acceleration are same, both positive or both negative. The body will accelerate, and when the sign of velocity and acceleration are opposite, then it means that body is retarded. Means this is the first point, and the second point, if velocity is equal to positive and acceleration is equal to positive, then you can say that means if it means to say that both velocity and acceleration have same direction. Both velocity and acceleration have same direction. Suppose a ball is falling downward. Its velocity is increasing in this direction and acceleration is also along this direction. Then it is the case of acceleration. But if velocity is if you are throwing the ball in upward direction and acceleration due to gravity is downward, then this is the case of retardation or negative acceleration. This is the case of retardation or negative acceleration, means velocity of the body is decreasing. So this is about the acceleration, retardation, and what is acceleration, all things we have discussed. Now let us see one of the question based on one of the numerical based on acceleration. Now dear students, look at the question in front of you and try to solve it based on simple question based on only on formula. You have to put the values and get the answer. And the question is starting from stationary proposition, means the body is starting from rest. A bus attains a velocity of 6 meters per second in 13 seconds. From rest, it attains the velocity of 6 meters per second in 30 seconds. The change in velocity you are knowing, final velocity minus initial velocity, and then 30 seconds. Then driver of the bus applies the brake such that the velocity of the bus comes down to 4 meters per second. After 30 seconds, the driver of the bus applies the brake and the speed of the bus reduces to 4 meters per second in next 5 seconds. Calculate the acceleration in both the cases. So you have to calculate the acceleration in both the cases. So let us see the solution. Very simple question. You must solve the question by your own. Case first. Case first. Initial velocity is u is equal to 0, final velocity v is equal to 6 meters per second, and time t is equal to 30 seconds. So acceleration is equal to final velocity minus initial velocity upon time. The final velocity 6 meters per second minus 0 meter per second upon time t, that is equal to 30 seconds, and it is equal to 0.2 meter per second square. This is the answer of the first case. And case second, initial velocity u is equal to 6 meter per second, final velocity 4 meter per second, and the time taken for this is 5 seconds. It is given in the question, 5 seconds. So acceleration is equal to v minus u upon t, that is 4 minus 2, 4 minus 6 meter per second upon 5 seconds, and it is equal to minus 0.4 meter per second square. This is acceleration and this is the case of retardation. Okay students, now average acceleration. Next heading is average acceleration. average acceleration. Since it is acceleration, then it is obvious that the average acceleration is the change in velocity, and upon change in time. So if we suppose at time t1 velocity is v1, at time t2 velocity is v2, then change in velocity, that is equal to delta v, and it is given by v2 minus v1, and change in time delta t, that is equal to t2 minus t1. So if you want to understand it by graphically, suppose this is the velocity axis and this is time axis, and a body is moving with non-uniform velocity. Since body is accelerating, we are discussing about acceleration, so it is obvious that it has not the constant velocity. The velocity is the velocity always changing with time. So this is the velocity at time, this is time t1, and this time, at this time velocity is v1, and this is time t2, and at this time t2 the velocity is v2. So average acceleration, so these two join these two velocities, and this is the time interval. So this, it will give the difference, that is v2 minus v1, and this difference can be given by t2 minus t1. So if it is a right angle triangle, then this angle is theta. So tan theta is equal to perpendicular upon base, that is equal to v2 minus v1 upon t2 minus t1, v2 minus v1 upon t2 minus t1, and it can be written as delta v upon delta t. Means slope of velocity time graph gives acceleration. Slope of VT graph gives acceleration. Slope of velocity time graph gives acceleration. So this is about the change in velocity during a time interval. Means, with an example I want to explain that. Suppose next heading is instantaneous acceleration. Next heading is instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration means that acceleration at an instant. Acceleration, just like instantaneous velocity we had discussed, instantaneous acceleration. Instantaneous acceleration is the acceleration at an instant of time, and if acceleration at a point of time or instant of time. Suppose this is your location, Divine Public School, Mohanapur, and this is your location, University Choraha. You had started your bike from here with a velocity of 0 meter per second at 10 a.m. And at University Charaha you had acquired the velocity of 30 meter per second, and you had reached here 11 a.m. 11 a.m. Or you can say that 10 a.m. means 10 minutes you had required. 10 minutes means 10 into 60. 1 minute has 60 seconds, so 10 into 60, 600 seconds. Means the average velocity that is equal to 30 meter per second minus 0 meter per second upon 600 second. This is the average velocity. But if you have to know your acceleration, at this point of time, that is 10:05 a.m. 10:05 a.m. At a particular instant of time, this time you have to know your, so suppose the velocity or odometer of your bike at this time is giving the speed 20 meter per second. 20 meter per second. And the time interval between this and this is 5 minutes. So 20 divided by 5 minutes, this thing gives you instantaneous acceleration. Means your acceleration at this point of time gives the instantaneous acceleration. So you can understand instantaneous acceleration as acceleration of a body at a certain instant or the limiting value of average acceleration when time interval becomes very small or tends to zero. Time interval becomes very small or tends to zero. So mathematically we can write it as A instantaneous delta t tends to 0 and it is equal to limit delta t tends to 0 del v upon del t and it is equal to dv upon dt. It is equal to dv upon dt, and it can be read as differential coefficient of velocity. Differential coefficient of velocity with respect to time. Differential coefficient of velocity with respect to time. So now uniform and non-uniform acceleration. What is uniform acceleration and what is non-uniform acceleration? What is uniform acceleration and what is non-uniform acceleration? Uniform acceleration means to say that if the velocity of the body is changing with a constant rate. And non-uniform acceleration if the velocity is changing with unequal rate, and uniform with equal or constant rate. First we will understand uniform acceleration. Uniform acceleration. Uniform acceleration, change in velocity. Change in velocity is equal in equal interval of time. Change in velocity equal. Let us understand that. Suppose you had started your bike and this is time and this is change in velocity. Change in velocity. So in time 0 second to 1 second, your velocity changes with initial in 1 second, that is at 0 meter per second, that is final at 3 meter per second. Means you had increased your velocity in this much interval of time by 3 meter per second, from 1 second to 2 seconds. Again from 3 to 6, means at 1 second 3 meter per second and at 2 second 6 meter per second. So 6 minus 3, that is 3 meter per second. Similarly, so on, means always in each second you are changing the velocity with 3 meter per second. In each second you are changing the velocity with 3 meter per second. Then you can say that your body is accelerating uniformly. Means you can say that your vehicle or your bike is accelerating uniformly. So this is about uniform acceleration. Next one is non-uniform acceleration. Non-uniform acceleration. No. Change in velocity is not equal in equal interval of time. Change in velocity is not equal in equal interval of time. Suppose here it is time and here change in velocity. From at 0 second it had changed from 0 meter per second to 3 meter per second. Means delta V is equal to 3 meter per second. From 1 second to 2 second, 3 meter per second to 5 meter per second. Means delta V is 2 meter per second. From 2 second to 3 second, it becomes, the change will become 5 meter per second to 10 meter per second. Means the change is 5 meter per second. Look at here. In each second, your velocity is changing at different values. In first second 3 meter per second, second 2 meter per second, in third second 5 meter per second, and so on. So you are changing your velocity with non-uniform rate. So velocity is changing at non-uniform rate, so it is called as non-uniform acceleration. So that's all for today, students. Thank you, students. And in the next video, that is on tomorrow, we will discuss 2 or 3 numericals based on acceleration, and after that we will discuss position time graph for positive, negative and zero acceleration, and then we will discuss velocity time graph for an accelerated motion. These two things along with the numerical we will discuss tomorrow. So that's all for today, students. Thank you. Have a good day. Take care.